You want to obtain a sample to estimate a population proportion. Based on previous evidence, you believe that the population proportion is approximately 0.62. You would like to be 99% confident that your estimate is within 5% of the true population proportion. How large of a sample size is required? So I'm going to show you two ways to do this. The first way is using the Libre text calculator. And before we do that, let's just write down what we know. Our confidence level is 0.99. Our error, or error bound, whether you want to call it E or EB, is 0.05, because that's 5%. And we're also told that the population proportion is approximately 0.62. That means p hat is equal to 0.62. That's our approximation of the population proportion. So I'm going to jump over here to our list of calculators, and I'll have a link to this in the problem, and go down to sample size for proportion. And in this case, we have an estimate for p, which is 0.62. And then confidence level is 0.99, and E is 0.05. We could calculate, and we get 626. So N equals 626 is our answer. Now, if you want to use formulas to do this problem, there are two formulas for sample size. One is when you have an estimate for p, so you have a p hat, and one is when you don't. In this case, we have a p hat, so we would use this formula here. And for a 99% confidence interval, z sub alpha over 2 is 2.5758. And the way you find that is you look at a standard normal curve. The area in the middle is 0.99. So the area in each tail is 0.01 divided by 2. And 0.01 divided by 2 is 0.005. And you just go to a normal probability calculator and compute this number here, z sub alpha over 2, such that the area to the right of that number is 0.005, and you get 2.5758. Okay, so now let's compute n. N is equal to p hat, which is 0.62, times q hat. Q hat is 1 minus p hat, so that's 0.38. And then we want z sub alpha over 2 squared, so 2.5758 quantity squared divided by our error bound squared, so that's 0.05 quantity squared. When we put that into a calculator, we get 625.25. And for sample size, we always round up, so we would take 626 as our sample size. And that's it.